Let's get started. I'm Marvin Timer. I'm a distinguished engineer over in AWS. And what I'm going to tell you about today is the larger picture of how AWS is trying to support event-driven computing. Now, probably all of you saw Werner's keynote, and probably Andy's as well yesterday. And one of the key things that we've been harping on is agility, right? And timeliness of things. And the key thing to that is event-driven computing is one of the key parts of that. Now, what Werner told you about in his keynote was primarily focused on Lambda, which is one of the ways of processing events. But you actually need events in order to be able to process them. And in fact, you need kind of a whole ecosystem in order to be able to put this together and really get sort of synergies that leverage it. And that's going to be the point of this talk, is to talk about that larger picture. So if you think about the traditional way of doing things before people started thinking about this event-based model, you do things like the following. Imagine, for example, your phone or your camera is going to upload an image file to your S3 bucket, right? You know, today, phones just do that automatically. They load into the cloud. If they're smart, they probably also index your photos so that you can find them by some efficient way, maybe by their GPS coordinates and so forth. But that's about what they do. That's what the phone does, right? Let's suppose there's this cool app that comes out that lets you create automatically photo albums where you take all of the photos that are from the same city or the same region or the same country, group it together, and give you kind of a nice travel log, right? Now, that's not something that's part of your basic phone functionality. So somebody else is going to develop that, and you're going to buy it, say. Or maybe it's free if you're lucky. Well, the question is, well, how are you going to use this thing? Well, you're not going to run it on your phone. This is going to do a fair amount of computing, and it's just not, it's something natural for the cloud, right? Well, it could be a web service, right? Somebody could create this as a third-party web service and say, hey, ship me all of your photos, and I will take care of this for you, right? Now, the problem with that is maybe you don't want to hand all your personal photos over to this third party, right? Now, you could try and buy this as an app that you actually run in the cloud yourself, but now you've got to remember to invoke it, and you've got to figure out which photos to run it over. If you're like me, you create thousands of photos on a trip, and you've got tens of thousands or more photos in your various buckets, and you've got to now figure out which ones am I going to run it over, which is tedious. Well, you could try and automate this stuff, right? You could set up a recurring workflow that goes in, scans your bucket, finds the new guys, and then runs it. But now you've got to remember to run this and then turn it off so that you're not paying for it for 11 months out of the year and so forth, right? And of course, you did this for one app. Now what happens? Another app comes along, say something that does face recognition and tags all your friends, right? You have the same problem. And when you got that one done, another app comes along and so forth, right? So the challenge here is event-driven computing is something that, well, let me talk some more about issues before I get to event-driven computing. There's another place where this shows up, right? I've talked here about something consumer-like, like uploading files to S3. Let's suppose you're a developer and you're developing some app that's going to involve launching EC2 instances. All right, so you do that. But if you're going to make your app fit into the larger ecosystem that your company has, you might have to do something like say, make sure that you're properly monitoring this thing, right? Suppose your app is highly available, and so you want to be able to detect if this instance went down. Well, you, the developer, right now, are going to have to make sure you set the monitors and the alarms on this thing. Did you remember to do that? Let's suppose your app has to be secure, too, and your company has an intrusion detection service that wants to know about all of the EC2 instances that are running for your company. Well, did you remember to tell it about it? Did you write that in your code? Or let's suppose your company's cost conscious, and they want you to tag that instance with the appropriate cost allocation tag so that your bill is done the right way. All of this stuff is stuff that a developer has to remember in order to write their application. So that speed of development has gone from, I wrote my app, I launched an EC2 instance, and I'm off and running, to I wrote code to launch an EC2 instance. Let's see, I have to go through the checklist. Do I do all the things the security guys want? Do I do all the things the monitoring and the operations guys want? Am I doing all things the finance guys want, right? And so the problem is we've slowed it down, right? This is the traditional way. Now let's imagine an event-driven world and how you would do things there. Well, your phone is going to upload that image to S3, and what you want is that an event is generated that can tell all the interested parties about that upload. Now what can happen is you can have things that respond to those events that do all these things that you wanted, right? You get your photo indexed by its GPS location. Some app that the phone never heard of is going to add all of the relevant things to the photo apps, to the photo albums, and yet another app that was written by an entirely different party can sit there and tag it with your friend references, right? And ideally, all you had to do was simply buy these cool apps. You didn't have to think about the management infrastructure. You didn't have to think about cooperation between the developers and so forth. Same thing if we think about the EC2 instance being launched. What you'd like is that an event gets generated, again, that tells everybody this instance was launched. And now in response to that, we can have the monitors and alarms being set by something like a Lambda function. We can have the intrusion detection system being notified, hey, they need to worry about this thing. And maybe those cost allocation tags are just, again, automatically added, right? And again, the ideal is you don't have to do anything as a developer other than launch that EC2 instance. All of these peripherals that you really don't care about as the developer of the application now get pushed away. And so that's the key value proposition here. This is what makes it agile. This is what lets you respond in real time and so forth. Well, so Lambda functions are part of that, but how do I get these events? And that's a lot of what this talk is going to be about. Now, if you get no help from the system, then life is kind of is pretty miserable, and you get these anti-patterns, which we see today. For example, imagine scanning, finding those S3 upload files, right? Here I've shown 3 S3 buckets with tens of thousands of files in them, or maybe millions of files if this is something bigger than that, right? How am I going to find the files that have changed? Well, periodically I do a list S3 bucket, and I'm going to get 1 million objects in here, say. And then these 3 objects come along, and now a little later, say a minute later, I'm going to do another list buckets, and I'm going to list that to find 1 million objects plus 3, right? And then I'm going to do a diff between these guys. And again, I'm going to be diffing 1 million objects in order to find 3 guys. This is very inefficient. I'm basically spending time proportional to the amount of data I've stored instead of time proportional to the number of things that have changed. We see the same kind of anti-pattern when it comes to state information in AWS. If you think about EC2, if you had some company that was running, say, those 35,000 instances that Netflix mentioned, if they wanted to know which instances have recently been created or recently been destroyed so they could have a dashboard of that, they'd again have to do the same anti-pattern. Describe the instances, get thousands of these guys back, periodically do it again, find those 3 guys that showed up, hello, and then do a diff in order to get 3 objects back, right? So what we really want is an event log. We want this idea that if data is coming in and being stored among this huge amount of data that's already there, that somehow efficiently the system would essentially give us a notification, a record for each one of these, because now we can turn this back to the old way that we know how of computing, which is we can now apply a function to this thing, like a Lambda function. All right, well, up till now, the only help that we gave you in AWS for this was CloudTrail. CloudTrail basically records all of the API calls that customers make to AWS, to most AWS services, and then puts them into a bucket for each customer. They group them out, and they give for each customer a list of S3 files that have a log of all of those API calls. So this is your first approximation of an event log, but it's not for everything yet, right? It's just for the API calls. So that's a good start. But we want more than that. And 2 of the things that we're announcing at reInvent that Werner has alluded to is S3 is going to start offering you the ability to get a queue of notifications for a bucket that you've enabled that way. So if you specify for your S3 bucket that you'd like to get notifications, those will get generated by S3. So you're getting exactly what I described I want for that image app, right? Now, event notifications actually can be consumed in 3 different ways. I've shown it here going to an SQS queue, but you can also have it go directly to Lambda so that you don't have to worry about managing that queue, or you can have it go to SNS so that you get notifications. The other one that we announced at reInvent is Dynamo Streams. This is Dynamo essentially exporting a transaction log of all the updates for a table that's been enabled that way. So again, if you specify for a given table that you'd like to learn about all the changes that have happened to it, what you're going to get is something that looks a lot like a Kinesis log, and it's going to be an exact transaction log of those updates with the order in which they were applied. So again, this gives you exactly what you need. And Lambda is integrated with this, by the way, or will be very soon, so that it will be able to consume these. So for 2 of these key data services, what we've given you is the ability to get exactly that event log in an efficient manner. But where we want to go in the long run is we want to have this be pervasive across all of AWS, right? So what we'd like to do is that for all of the, like CloudTrails currently gives you a log of all of the synchronous API calls that clients do, we'd like to give you an event log for all of the asynchronous service events that might happen. Because wouldn't it be interesting to know if an EC2 instance terminated without your having called terminate? Wouldn't it be nice to know that a bucket got deleted, or a table got deleted, or an RDS-HA instance did a primary failover? These are all events that we record in the control plane of our services. And we'd like to expose those to customers so that they can then leverage that, right? The other thing we'd like to do is for all of the other data storage services that we've got, we'd like to give you that same ability to optionally specify, for this entity, like a Redshift table or something like that, I'd like to get an event log of all the things that have changed. So our vision for the long run is that all of AWS is going to give you these kinds of event logs so that you can then start using things like Lambda or other things like that in order to have this event-driven style of computing. So what we're aiming for is a unified vision of event logs, right, where the whole platform is going to support this. But there is a challenge here. If you'll notice, I talked about S3 publishing to an SQS or to SNS, and I talked about Dynamo streams being a Kinesis-like thing. And you might be going, wow, OK, so how many of these things am I going to have to learn? Am I going to have to learn how to program against Dynamo streams, against SQS queues, maybe against this archive format that CloudTrail provides for writing things out as a sequence of S3 objects? There's a Kinesis stream. Some people might use Kinesis streams in order to publish these events. Is that going to be different from the Dynamo streams? Is somebody else going to come along and say publish a different S3 archive object format? All of these things are different, and what we want to avoid is that Tower of Babel and get to the point where we have sort of a minimum number of these frameworks that you have to learn about. And we think that the minimum that has to be supported is 2. In particular, you want to be able to support both ordered and unordered event logs, because there's a fundamental difference in the complexity of processing these things. But what we'd like there is to essentially all the services to emit logs in these 2 forms, and then enable the ability to have transformers that allow you to convert them to a form that you might want, right? So for example, if somebody published to SQS and you wanted SNS notifications to your phone or to your email, there should be an easy converter that can say consume that SQS queue, a Lambda function or something, and then puts it into SNS, right? So that's our vision of where we want to go. Now, the benefits you get from doing this as an ecosystem where everybody participates is kind of like what we've seen with storage systems. Think about the file system on your disk of your machine, right? That disk at the lowest level is just a sequence of bytes being stored persistently, right? The first thing people did is they put a file system on top of it. Why? Well, that way everybody can have their own separate sequence of bytes, and you can start building these tools that allow you to manage and manipulate byte sequences, right? You get a file system with move operators. You can list the files. You can do all this stuff without knowing anything about what's in the files. But then on top of that, what you can do is start putting structure onto the format, onto the data itself. And now you have application-specific state, and you can start building tools around that, right? You can build tools around, say, a specific type, say all the things around Word files, but you can also build tools that are more general. Just think about how search is implemented on your disk. Every file type that has strings in it is searched by the search facility, right? So if I know enough about the types, then I can start doing this kind of thing where I build search across a large fraction of my files because I know what kinds of data formats are there and what the standards are on that. So we'd like to do the same kind of a thing for event logs, right? At the bottom, an event log is just a sequence of uninterpreted records. But really, what you'd like to do is have lots of them so that, say, each service can have their own or each customer can have their own. And you'd like to start building tools that take advantage of that, that manage and manipulate sequences of these records. Imagine, for example, I want to archive my event log. Well, it should be really trivial to build a tool that says, hey, plug this into SQS or into any of these kinds of logs and just archive it, right? And then if I start adding standard type information to this so that I have semi-structured data, then I can start building things that are at a more sophisticated level. One example of that is Dynamo update streams. These are ordered streams, but since you know they're Dynamo streams, you can build something like cross-region replication for any Dynamo table simply by knowing this is a stream of update records for Dynamo. And I'll talk a little bit more about that later on. So this is sort of the benefits you get by building this kind of ecosystem. Another key thing you get out of that is that you get a reusable processing infrastructure. Processing these things is actually not trivial. For example, think about the scale that you have to do for this. If I have a DynamoDB table or S3 bucket, I may be getting huge volumes of data in, right? Now, as long as that data can be handled by a single process, I'm fine. I just run, say, one EC2 instance. Lambda will try and abstract this out, but Lambda has to implement the following kinds of things. If I have data that's more than one machine can handle, then I'm going to have to run multiple of these machines and manage that, right? If I want high availability, because if these event logs are not as available as the services themselves, then I've kind of added an Achilles heel to the availability of my services, then what I've got to do is be prepared for the idea that one of these processing instances crashes, and somehow or another I've got to do something that allows me to get a new one to jump in there, take over where the old one was going. Whatever checkpointing happened, I've got to take care of, I've got to get that checkpoint and then keep going. And then, of course, because things are elastic, it gets even more complicated, right? Here I am. I've got a stream that started out small. Say it's a service that, I have an S3 bucket where I just started with my photo app. I'm getting a little bit of traffic. But then I get a lot of popularity. And now I'd better essentially ramp up, right? But maybe during the night this thing dies down. And we don't want to pay for these instances if we're not using them. So I've got to essentially get rid of that. And then if there's, say, a hotspot in one spot, I've got to be able to do something like load balance and have some of that traffic be taken over by another instance that jumps in. All of this muck is stuff that you don't want to deal with, right? So the goal is you've got to have some standard processing frameworks for this. Lambda is one of those, but in order to do Lambda, you need some low-level processing infrastructures in order to enable things like Lambda. At the lowest level of abstraction, you've basically got this uninterpreted sequence of bytes. And as I said before, a key characteristic that you have to think about is whether you've got ordered records or whether you've got unordered records. An example of ordered is the Dynamo streams. Why would you want that? Well, because if I'm doing something like representing a bank using DynamoDB, where, say, each item is a bank account, I really care whether the order of deposits and of deposits and debits is done in the right order. Say I do cross-region replication on this, and somebody's looking at my bank account on the other side. If I do these out of order, my bank account could go below 0 or do other weird things, right? So order matters, and so you have to have it. If order doesn't matter, like, for example, uploading those image files into S3, they're really all independent of each other, right? So order is not important here. And if it doesn't matter, then you want to take advantage of that because it turns out you can build a simpler processing model that actually has greater concurrency. And so what we need is to be able to support both. SQS provides you a good way of processing a low level when things are unordered. Imagine all of those records coming into the SQS queue. Basically, I can have a fleet of stateless machines that sit there just grabbing things off the queue and then doing whatever they're doing, maybe putting out that thumbnail there. And if somebody in the middle, say that middle guy, is busy processing an image file that is a 4 gigabyte sized file or something, everybody else can keep going around it. It's a very simple processing model. So that is a simple thing to do, and in fact, that is the kind of thing that Lambda is best for, because Lambda is most naturally a case where you have functions that operate independently on individual data items. Allows for huge concurrency, has a very simple high availability model, and so forth. But if you want ordering, and you can take advantage of things like auto-scaling groups in order to be able to get the availability on these guys. If you want ordering, things are more challenging, right? Because if, say, I had a total order for my event log, I've got a problem here. If that event log has more traffic than a single machine can handle, how am I going to honor the ordering? And a key thing that turns out to be true for most applications that need ordered logs is there's actually only a partial ordering that's required. I've shown that here in this event log. You can imagine that this event log, that the records that have an ordering constraint with themselves are the ones with the same color. What would be an example of this? Well, think about, say, the metering records that we use in AWS for your bills. Well, every customer gets their own set of usage records. And I care about the order in which those show up because of a variety of ways in which you calculate the costs, but every customer is actually independent of each other. So what I could do, instead of overloading this one machine and processing everything, is I can have a bunch of machines and partition this log out by the partial order. And so what can happen is if I did this, where I essentially say everybody that belongs to the same ordering constraint is going to be grouped together, then I can parallelize this thing out. I don't have the full concurrency of the unordered model because I have this constraint now that record 6 has to be after 4, and record 6 had to come to the same machine that was processing 4, but I can scale this thing out quite dramatically. So in order to do this, if you ask, well, what kinds of machinery I need in order to implement this, well, this is what Kinesis and the Kinesis client libraries do. And I'm not going to go into the details here, but just to illustrate, this is what it takes in order to give you that processing model. It's considerably more complicated, right? So that's why if you can stay away from ordering, you want that simpler model. If you need the ordering, we're going to enable it with a framework that takes care of that. And as I said, KCL actually enables you to do this. So at a low level, you've got 2 frameworks already for processing things. You could run, say, with SQS and have a fleet of your EC2 instances. You could run with the KCL and a fleet of EC2 instances that will give you complete control over doing these things. One thing that you may have noticed is that I've been talking about Kinesis as our standard processing framework, and yet if you were to go read the details of Dynamo streams and compare them to the Kinesis API, you'd notice that they're slightly different. You'd notice that there's a different maximum record size that Dynamo offers from Kinesis, and this has to do with the internals of Dynamo. Eventually, this is going to disappear, these differences. You're going to notice that DynamoDB controls pretty much all aspects of writing to streams. So names of streams, provisioning of the number of shards, resharding, all of that stuff is handled by DynamoDB, whereas Kinesis allows you to control that. And the APIs are also slightly different. In DynamoDB, the list stream and the describe stream APIs return service-specific information such as the table schema, right? So it's different, and you might be going, well, geez, did you guys just do the thing that you were not supposed to? I have to learn Dynamo update streams, and I have to learn Kinesis? And the answer is we've abstracted it out at the Kinesis client library level, and so if you program using that library, you are oblivious. You're agnostic, essentially, to whether you're programming against a DynamoDB update stream or against a Kinesis stream. So we are trying to keep it down to basically 2 processing models at the low level. Well, once you have this stuff, now you can start building these higher level things, right? If I was describing, part of the reason I described the whole SQS model is because you could think about that and say, I can see how Lambda might be implemented on these things, right? And so at the next level up, Lambda essentially takes advantage of these lower level processing frameworks in order to give you something that gets rid of all of the muck of the management, right? No more AMIs, no more launching those EC2 instances, no auto-scaling groups, and so forth. One interesting thing, though, that happens once you give people something like Lambda is they start going, well, wow, how many Lambda functions have already been written that I could just reuse? Like, I really don't actually want to write any code myself. Can't there be an ecosystem of functions that somebody else has written? And so there's an opportunity here that once we give people things like Lambda, various third parties can start building things like an archive to S3 capability, or an update to Redshift capability, or a publish to SNS. All these things can start being provided, and because we're trying to standardize so that everybody is giving you the same types of event logs, and everybody knows that there's certain standards about the data the data formats and so forth, that's going to enable people to start building these tools that can be reused, right? So I'm going to hand over to my colleague here, and he's going to give you an example of how this can dramatically speed up the rate at which people build things, not just an individual developer, but in fact, people that never know each other.
Thanks, Marvin. So let me see if I can switch over here or not. All right. So picture yourself in the shoes of a developer who's amped after attending reInvent, and she's met a couple of other people who she wants to make a startup with, but she doesn't know that yet. At this point, she wants to make something to do with social networks, let's say an image sharing application. So she starts by writing a simple application that uploads the apps that her end users are taking from their phones directly into S3. Now, ST's got her covered with 11 nines of durability and exceptionally high availability. So that's all good. And now her users can upload these photos and just be able to download them as they see fit. Another one of her friends basically comes in and says, well, I want to be able to index these images. I want to make a web UI for all the photos that people have uploaded, because I want to let them do more than just backing up of the pictures. I want to let them search for just not only their photos, but photos of their friends and so forth. So now this friend is coming in and saying, well, I want to extend your application. And I don't want to go ahead and force you to rewrite your entire stack. I want to be able to extend on top of what you have already built. And at this point, with the original developer's permission, all you have to do is add a Lambda function that attaches to the S3 bucket. In the S3 console or in the Lambda console, you can actually create a configuration that allows you to attach a Lambda function that will be executed every time an update is made to this bucket. Now our friend, the original developer, Sally, has given permission to her friend to be able to subscribe to these events, so every time a new image comes in, his program gets a notification and executes a particular Lambda function. Now this Lambda function you might think is actually a lot of code. It's not. It's only about 20 lines of code, and I'll show you that in a second. A third developer comes in and says, well, I want to be able to give people the ability to like a particular image. All right, so the natural place to store that is another DynamoDB table where you're going to store all the likes. So this says things like Marvin likes a photo X that Quadja has taken. And now these users have the ability to start liking photos. Well, the second developer is saying, well, I've got all these pictures indexed by their image names and the person who was taking the image and so forth. I want to extend what the third developer has done as well. I want to be able to track how many likes a particular photo has gotten. So he attaches another Lambda function to the DynamoDB streams of the likes table. And this function is all it's doing is subscribing to the events that are happening in the likes table, figures out which image was liked, and goes and increments an atomic counter in the images table to aggregate the number of likes that a particular image has gotten. Now, after he realizes that he can now track the number of likes that a particular image has gotten, he also wants to track who the most influential users are in this ecosystem. And to do that, he wants to aggregate all of the likes that a particular user has gotten across all of their images. So he goes back to the Lambda console, makes a quick modification, and all of a sudden his code is updated to also aggregate the likes across all the pictures for a particular user. All he's doing is when he updates to the images table, he finds out who the user is that uploaded the image in the first place, and he goes and updates it into the users table in terms of the total number of votes that a user has gotten. Now this is interesting, right? Because you want to be able to track who the most popular users are in your ecosystem so you can engage them and you can encourage them to upload more photos that drives the engagement of the rest of the community. A fourth developer comes in and says, okay, so now you've gotten to me the number of votes that a particular user has gotten. And now you know who the most influential users are, and I want to be able to engage them. And one of the natural ways to engage with users is via SNS mobile push notifications to send notifications to their cell phones. So with the third developer's permission, this fourth developer comes in, attaches to the users table's DynamoDB streams, and upon every change that is being made, he can see if the user is particularly popular or not. And if any user is particularly popular, you can engage with them via SNS mobile push. Now, there's a lot of different things you can engage with them on. You can engage with them to tell them to come in and upload more photos, or you can engage with them and tell them, hey, please go ahead and send this advertisement on my behalf. And since you have a bunch of fanfare, you'll get this notification pushed out and more people will get visibility and so forth. The point is that when you're building these applications, you're not going to need to know all of what your capabilities are for this particular application up front. And what Lambda and event-driven computing gives you is the ability to continuously compose new capabilities without having to deploy entirely new stacks, without ever having to deploy a full stack for every new functionality, and without having to disrupt the existing stacks. It allows you to deploy a function, attach it to a particular event, and let it run regardless of the capacity that you need. You don't have to worry about that. You don't have to worry about the operations. And you can automatically react to events. Now, I mentioned all of this is a very low amount of code. So let me go through and show you how much code we're actually talking about. So the first function that is subscribing to S3 and inserting data, indexing the images directly into DynamoDB, it's about 20 lines of code. The second function, and this is after the modification has been made to also aggregate the total votes a particular user has gotten, it's another 20 lines of code. And the third function is about 15 lines of code, which is basically looking at the users table, identifying the popular users, and sending them an SNS mobile push notification. The message here isn't that you can write this cool startup with 50 lines of code, really. The message here is the composability. It's the ability for multiple people to work together and continuously add functionality in form of a crowdsourced startup that you can continuously keep adding capabilities without ever having to worry about operations and so forth. And the reason why this works really well with S3 and SQS notifications is that you don't really need to worry about the order in this particular case. It doesn't matter which image you process after the other. And this is why S3 also exposes these notifications via SQS or SNS notifications. So you're able to consume these with EC2. You're able to consume this with Lambda if you choose to. The difference is mainly along the lines of the new way to think about an application and the ability to decompose that application into lots of small pieces that you can write yourself or have others write with you. Martin?
Somebody started out with a fairly simple app, load a bunch of stuff into S3. And then a bunch of other people realized they could do something interesting with what was done there. And without having to go to the original developer and say, hey, can you add this in? You send them an email, maybe a day later they come back and say, I'll think about it, and a week later they do it. If it's been exposed, if this data has been exposed in this event-driven style with these event logs, you can simply add it yourself. So that second developer, an hour after they see this thing starting to go off, can add this functionality. And all they had to do was get the permission from the first developer to have access to that event log. And if you're, say, building something where you're looking for adoptants and you're willing to make those event logs public, you could imagine putting this thing out, and now anybody in the world, people you don't know, could sit there and go, cool, I'm going to add my functionality on top of this thing. And you could get this very viral behavior where in a very short period of time, you could imagine in a day that something like this takes off and people start adding in cool things, the image recognition, the liking, adding in all kinds of other things that build on top of that. And as long as everybody's thinking of it in terms of publishing events in a form that adheres to some of the standard formats so you know what you're dealing with, then this thing can just build very quickly, right? So we've taken the cycle time down from weeks to days and hours, we hope. Now, another example of something you can build that's reusable is the cross-region replication that I mentioned. Dynamo will give you basically an exact transaction log for a table if you enable it that way. And what that means is you could build a Lambda, you could build something that will take those and go update the corresponding table in other regions. Now, order matters here, and so just using Lambda out of the box would be a little complicated because you wouldn't get, you have to worry about implementing those ordering semantics and so forth. And Lambda is eventually, we imagine that Lambda is eventually going to evolve to the point where it starts giving you some support around it. But right now, the best way to do this is with a more lower level framework like these Kinesis-enabled processing framework that I mentioned earlier. And in fact, we've released as open source exactly this. Cross-region replication is available now as a KCL-enabled Java app that you can run, so that if you enable the streams from DynamoDB, you can now get cross-region replication for yourself. And if you wanted to do something like derive from this, say, the idea of I have some materialized views that I want to derive from my table, I could take that code, which is open source, go look at the business logic in the middle that's relatively small, replace that with something that essentially now implements my materialized views, and I'm off and running. So again, we've compressed the cycle time for development dramatically with this. Well, so you might be wondering, how many event logs am I going to have to deal with, right? There's a lot of AWS services. Am I going to have to deal with an event log from every service? And in fact, because we don't want to allow customers to see each other's events, am I going to have an event log per customer per service? Well, it'd be nice if I had that. It would certainly make it easier for customers to be able to understand what happened with their service. Imagine my service starts behaving in a funny way, right? Now I can go to the event log for that service and say, hey, so what just happened? And if it's like, say, oh, I see an EC2 instance is terminated or something like that, or this table got deleted, no wonder things aren't working, that works well. Not so easy if I have these event logs for each service, for each customer, to understand what's going on across, say, lots of services. So if I had one of these things that Werner showed where you're using RDS and you're using S3 and you're using DynamoDB and you've got maybe a CloudFormation thing going on and CloudFront involved, well, now I've still got to figure out what's going on across all of those things. So that's still a little bit more complicated. And again, if you think about the data plane, if you think about the data going through S3 or DynamoDB, you don't really want to have an event automatically published for everything going there, right? You only want it selectively for the entities, the S3 buckets or the DynamoDB tables that you care about, right? So what we think is going to be the right architecture to provide across AWS is one where we provide each customer with an event log for all of their so-called control plane events. What I mean by this is basically imagine taking CloudTrail, all of the data there, but then also all of the interesting events that happen that aren't synchronous customer API calls. Things like your table got deleted and you're not quite sure why, or your EC2 instance terminated, or you had a failover. All those things I mentioned, those are events that are not part of CloudTrails right now, but we'd really like to get those in so that you basically have one event log that tells you all of the activities that are going on across all of your resources at that control plane level. Now, luckily, the traffic volume for that kind of stuff is low enough to where we think just giving you one event log for all of that will be reasonable. And you can just apply filtering if you want to look at individual parts. And so with this, you're going to have an easy way of understanding what's going on across your entire AWS resource plane. And then what we also want to do is, if for each of the data services, we want them to start exposing the idea of an event log for their entities. So if you had something like a DynamoDB table or a Redshift table, that would be the kind of thing that we envision having an event log for. Well, I've talked about AWS services so far, but really, this should be extended up to our customers, right? Customers are going to be building services and applications, and it seems like the same argument for why that would be useful down at our level should apply to their level. And so what we need to do is enable that. And what that means is that we're going to have to allow customers to submit their own control plane events that can be added to the unified control plane event log that I talked about. And we're going to want them to start thinking about their data in the same way that we think about DynamoDB and S3. So if you had, say, widget.com, which had widgets, you can imagine them starting to say, well, I'd like to have an event log per widget. And what that means is we've got to make it easy for them to create these event logs. Luckily, things like Kinesis Streams allow you to do exactly that. So to summarize, what the point here is, agility and timeliness is a key thing in today's world. And as Mark Andreessen says, the cycle time compression may be the most underestimated force in determining the winners and losers in tech. So we want to essentially enable people to win here. And what that means is we want real-time events to let you create real-time applications. We want you to have a platform architecture where published events let third parties independently innovate on top of each other. We want this platform-wide architecture to be something that essentially is going to start an ecosystem, and we need low-friction pieces that will allow you to not have to deal with the muck. Things like Lambda are examples of that. So what you need as the enablers to do this is you need the efficient way of surfacing events. You need standards so that you can know what's inside of those and build ecosystems at various levels of typing. And you need those low and high-level processing frameworks. What we've got, well, CloudTrail existed beforehand. We announced at this reInvent the S3 event notifications and the DynamoDB streams, and we've announced Lambda. And where we hope this goes in the future is that now you guys will all build an ecosystem around this, right? We're essentially enabling you to find and discover, to enumerate and discover event logs. We're going to be defining standards so you have some idea of what's in these guys at various levels of the stack. And we're giving you these standard processing frameworks so that you don't have to do anything other than write your business logic. And we're hoping that a marketplace is going to be created out of this where people can either put up free or for-fee software and services that essentially provide these higher levels of functionality, right? And at that point, when there's a marketplace and I can find all the event logs and I can find all of the apps that you guys, all of the Lambda functions, other things you guys have built, we hope this is going to explode into this giant ecosystem that's going to accelerate everything dramatically. So with that, I'll be happy to take questions. I will say first, there are deep dive sessions into both the S3 event notification stuff and the DynamoDB streams, and I've listed which sessions those are on the right of the slide. So with that, I thank you, and if you want to ask questions, we, I think, have a few minutes to do that.
Consistency guarantees with the event notification and the corresponding trigger of the event?
Yes. So if you have an ordered log, the idea of that is like a transaction log, a highly reliable transaction log.
So with S3?
And with S3, the durability of the notifications is intended to be about 9 nines. So basically, you will get the notification for everything that happens. You basically don't have to worry about whether it was missed. Nothing is perfect. And so you may want, as a best practice, have ways of determining whether more likely your code did had a problem. But we're aiming at 9 nines of availability for the S3 event notification. Other questions? Mm-hmm. You get it back, and that's why I used SQS as the example, and Lambda follows the same semantics. In SQS, you dequeue an event, and that locks it so nobody else can use it. And then when you're done processing, you go in and you delete it. If you fail, it's still there, and it eventually times out, and it's still there. Now, this is an at least once processing model. In fact, all of these things really work most naturally with at least once processing, because if you think about it, in order to guarantee that you see everything, we need to give it to you multiple times, right? If I fail in the middle of something, I'm going to roll back to a checkpoint, whether it's this timeout in the SQS or whether it's a checkpoint in the Kinesis logs, and I'm going to replay things. So you've got to be thinking about these things as being idempotent processing functions that might get reapplied, but you're guaranteed to see everything at least once. That's the model.
Are there, with Kinesis or SQS,
Mm-hmm.
that is frequently a rather costly and difficult proposition to do right. Is there anything, particularly as moving to Lambdas, where you have no real, beef behind you? Is there anything to help with idempotence, like the example we had here with incrementing votes? That is an idempotent safe, for example.
It can be, actually. You can make it idempotent by using conditional puts in DynamoDB. So you can use things like the list data structure in DynamoDB to count who has actually voted, and then do a conditional put for the increment of the vote if and only if that user is actually not in that list already. So like things like conditional puts help you a lot with respect to maintaining the idempotency, and there's other tools that you have at your disposal as well that we can discuss.
So there's similar techniques that are sort of point solutions. You can do sort of deduplication style of approach. Conditional put is kind of that. You can do that. Kinesis uses that in a variety of places. One thing I dream about is taking that to the next level up, where then you don't have to think about that at all. But that's future work. At the moment, it's not trivial to write idempotent applications. That's absolutely true. But these are steps, and there are a lot of things that you can write idempotently, and so we think this adds significant value above not having anything at all.
There's one question there as well, but let's bet.
Okay. Anybody else?
Do you still have a question?
I was going to ask about replaying streams.
Yeah. Replay a stream? Well, sure, because the idea here is these are logs. And the way you process them is you have a cursor. The client application has a cursor to run through them, right? So the model is, as I'm running through, I typically will do, what you want to do is do a checkpoint at various points. That's going to write, say, to DynamoDB or someplace, here's the sequence number that I was at in the log. Here's my state that I was processing in my app. And now if I crash, I go back to that and I replay, right? I could also, but I can keep that log, right? One of the things I mentioned that's a useful general functionality is, say, an archive to S3, right? You could imagine taking those logs, archiving them into S3 or maybe even into Glacier, and then periodically, say, rerunning a what-if thing, right? So something that people have talked about is like archiving all of our billing data and then being able to rerun something that says, well, what if I had a different pricing model? Well, I could rerun it across my billing data, my billing log, if you will, and see what that would make, what difference that would make. Again, these are things you can build up as additional functionality on top, and what we're hoping is people are going to start doing all kinds of stuff like that. All right, last question. I think we've exhausted you, so thank you very much.